is a radian? Let's just say you're on a desert island all alone with only a piece of string like the one below and a lot of time. What is the most natural thing for you to do with the string? Use it as a radius to create a circle in the sand, of course. Because the string is the radius of the circle, we can use it to measure. So the radius itself becomes a unit of measure that we can then call radius units. The difference between this ruler and rulers that we've used in the past is that this one's made of string, which means it's flexible. This now allows us to measure length along a curve. Let's go back to our circle. Let's use radius units to find the length of A. So what's the length of A? Remember, 1 unit of ruler is equal to the radius of the circle. So if this is 1 radius unit, then A equals R. The arc A is equal in length to the radius of the circle R, so A equals R. Earlier, we discussed how arc length was dependent on 2 things, angle measured and side radius length. Let's see what happens when we use radius units instead to measure arcs. Do you notice anything? Discuss your observations. Let's bend our radii segments around the circle so that they look like this. When using radius units, the angle created is independent of the length of the radius, which means that radius units measure angles. Now we will find the length around a full circle of any radius. Using the circumference, we know that c equals pi times d, which is circumference over diameter equals pi. Diameter is also 2 times the radius, therefore 2 pi equals circumference over radius. Using arc length, we know the arc length equals pi r theta over 180, or 360 pi r over 180, which equals 2 pi r. So s over r equals 2 pi, which is the arc length over the radius equals 2 pi, and you still get to circumference over radius equals 2 pi. This is the same. In both cases, ratio between the circumference and the radius is always 2 pi, which is approximately equal to 6.28, our original radian estimate. Radius units is a terrible name, so we shorten it to radians. The definition is a central angle of a circle has a measure of 1 radian if the angle intercepts an arc with the same length as a radius. So if this length here is the same as this length here, then that angle is 1 radian. Why do radians measure angles? Let's go back to circumference and arc length. First, about how many radians are in a circle? It looks like just slightly more than 6 radii fit around the circle. We can approximate this to about 6.3 radians, or equivalently 2 pi radians. Let's use what we just found, 360 degrees equals 2 pi radians, to make conversions between degrees and radians. When we simplify, we get that 180 degrees equals pi radians. So to go from degrees to radians, we will multiply the degree by pi over 180. So that converts 60 degrees into radians. To convert radians to degrees, we flip the fraction over and we multiply the radian by 180 over pi. That can convert something like pi over 15 into degrees.